Welcome, architects and developers. Today we are taking your Retrieval Augmented Generation, or RAG, skills to the next level. We are moving beyond basic similarity search to explore two powerful techniques, multi-query retrieval and maximum marginal relevance. Let's get started. Let's define our starting point. For most RAG applications, the default retrieval method is a standard distance-based semantic search, typically using cosine similarity. While it is a great baseline, it hits a wall in production. Standard similarity search is incredibly literal. It relies strictly on the geometric proximity of embeddings. If a user asks a vague question, the vector store returns narrow results. If the database has 5 identical paragraphs about a topic, standard search will gladly return all 5, wasting your LLM's precious context window. To build production-grade systems, we have to move beyond this. We need to manipulate the query before it hits the database and intelligently filter the results after they come back. This ensures we maximize both relevance and context diversity. Looking at this flowchart, you can see the two main bottlenecks of basic search: vocabulary mismatch and redundant context. When a user's wording doesn't match the database, we route the strategy through multi-query retrieval. When the database returns repetitive noise, we route through maximum marginal relevance, or MMR. Both advanced pathways converge at the bottom, delivering high-quality, diverse context to the LLM. Why exactly do we need to upgrade? Let's look at the basics of why standard search falls short. First is the vocabulary mismatch. Your user might search for global warming, but your highly technical documents only use the phrase climate shifts. Because the embeddings are slightly different, the best documents might be missed. Second, consider redundancy. If you ask a standard retriever for the top 5 documents on a topic, and your database contains 5 identical copies of the same policy, you get 5 identical chunks back. You have now wasted your LLM's context window on repetitive noise, starving it of the comprehensive data it actually needs to synthesize a complete and accurate answer. This diagram illustrates the redundancy trap perfectly. The user asks a broad question about climate change. The vector store performs a standard top 3 search. Look at the results. Document 1, 2, and 3 all focus exclusively on sea levels. We completely miss temperature changes or carbon emissions. The result is a wasted context window filled with duplicate semantic meaning. To solve the vocabulary mismatch, we use multi-query retrieval. How does it work? Instead of sending the user's raw, potentially flawed question to the database, we intercept it. We use a smaller, fast LLM to generate, say, 5 different versions or perspectives of that exact same question. By doing this, we cast a wider semantic net, overcoming the limitations of strict distance-based similarity. We then take all 5 of those queries and execute them against our vector database in parallel. We gather all the retrieved documents, flatten the list, and deduplicate them to get a unique union of documents. This guarantees that, even if the user asked the question poorly, one of our LLM-generated variations will hit the right semantic cluster. Follow the data flow here. The user query enters the LLM rewriter at the top. The LLM spawns query 1, query 2, and query 3. These branch out and hit the vector DB concurrently. The database spits out multiple lists of documents, which all funnel down into the final node where we deduplicate and take the union. We've effectively broadened our search horizon without manual intervention. Let's deep dive into the code implementation using LangChain. You don't have to build the deduplication logic from scratch. LangChain provides the multi-query retriever class. You simply initialize it by calling multi-query retriever.from LLM, passing in your standard base retriever and your LLM. Under the hood, you can supply a custom prompt telling the LLM to generate exactly 5 variations separated by new lines. We then use a specialized parser, like the line list output parser, to strip the raw text into a clean Python list. The retriever automatically uses the .batch method to run these queries concurrently, meaning your latency impact is minimal while your retrieval quality skyrockets. This sequence diagram maps the internal operations of the multi-query retriever. Your app calls invoke. The retriever seamlessly talks to the LLM to get the 5 variations. Notice the batch retrieve step. This is crucial for performance. The vector DB hands back multiple document lists, the retriever dedupes them internally, and your app receives a perfectly clean, diverse set of documents. Now, let's solve the redundancy problem using maximum marginal relevance, or MMR. MMR is a brilliant algorithm designed to balance exploitation, which is relevance, to the query with exploration, which is diversity among the results. How does it achieve this? It calculates 2 things. First, a relevance vector, which is your standard similarity score between the query and the documents. Second, it calculates a redundancy matrix, measuring how similar the retrieved documents are to each other. As it builds the final list of documents to send to the LLM, it looks at the highest scoring relevant document and actively penalizes any subsequent documents that are mathematically too similar to it. It forces the system to pick documents that offer new information. Look at the mechanics of MMR in this flowchart. We start with a large pool of documents. We simultaneously calculate how relevant they are to the query and how similar they are to each other. The MMR formula node applies these two metrics. It selects document 1 based purely on high relevance. But for document 2, it demands high relevance and a high mathematical difference from document 1, ensuring a diverse context. Diving into the MMR implementation, we work with two distinct size parameters, fetch k and k. We might tell the database to fetch k equal to 20, pulling a large initial pool of candidates. We then filter that down to k equal to 5 for our final output. The magic happens via the lambda multiple parameter. This is a dial you control. The algorithm takes relevance, multiplies it by 1 minus lambda, and subtracts the redundancy multiplied by lambda. If you set lambda multiple to 0.5, you are demanding an exact 50-50 split between relevance and diversity. In LangChain, you execute this simply by calling max marginal relevance search on your vector store, passing your query, k, fetch k, and lambda multiple. It is a single line of code with massive architectural impact. This diagram visualizes the code parameters. The query hits the vector store, but notice the edge, fetch k equals 20. We pull 20 candidates into our pool. The pink node applies our mathematical lambda filter, aggressively discarding the clones. Finally, it outputs exactly 5 highly diverse documents, represented by k equals 5, ready for the LLM. Let's apply this to a real-time, high-stakes use case, a financial advisory agent. A user submits a vague question: what happens if I take money out of my 401k early? Basic search might just return 5 identical paragraphs stating there is a 10% penalty. Our advanced pipeline intercepts this. Multi-query retrieval expands the vague question into specific queries about tax implications, age exemptions, and hardship rules. We fetch 30 documents across all these queries. Then, MMR steps in. It evaluates the 30 chunks and ensures the final 5 documents selected cover the penalty, the tax bracket changes, and the specific hardship exemptions, rather than 5 clones of the penalty rule. The LLM now has a perfectly rounded context to generate a flawless financial summary. To master these advanced RAG techniques and more, be sure to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram brings it all together. The vague query enters the multi-query node, which expands the intents. The vector DB fetches a massive pool of 30 documents. The MMR node acts as our strict bouncer, filtering out the redundancy. It passes exactly 5 distinct, highly informative contexts to the LLM, which ultimately generates a comprehensive, expert-level advisory answer for the user.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechit.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.